In my last video, we have seen the first normal form, which is a CNF, and now we're going to see what is called as a Greibach normal form or GNF. So we have already seen the definition. In CFG, G is said to be in GNF if all the productions are of the form A derives A alpha, where A belongs to T and alpha belongs to V star. That is nothing but, so on the RHS, you should have first symbol is a terminal followed by any number of variables. That is, the first symbol on RHS of every production must be a terminal. So the productions on the RHS must start with a terminal followed by 0 or more of non-terminals. So for which we should know what is first left recursion elimination. So first is left recursion. What do you say that a grammar is having left recursion? We have to see first. A CFG is left recursive if it has the terminal A such that there is a derivation of the form A derives A, that A alpha. That means the left hand side variable appears as the first symbol on the right hand side, then we can say that it is left recursive for some alpha belongs to V union T whole star. So if AI derives AJ star, where I less than or less than J is the required form. So you should bring it into this required form. So next we will see the construction of GNF. So first is the elimination of left recursion. So let G is equal to BTPS be a CFG. Then the set of A productions be A derives A alpha 1, A alpha 2, A alpha R, or beta 1, beta 2, beta S, where beta is do not start with A. So here you can observe these are all the productions which are generating the left recursion which are to be eliminated. And these are beta 1, beta 2 or the productions of A which do not start with A. Now we will introduce a new variable Z and let G is equal to V union Z. So we have added a new variable into the set of variables, and T is the set of terminals, P1 is a set of new productions, and S is a start variable where P1 is defined as below. First is set of A productions in P1 will be A derives beta 1, beta 2 which are in the correct form, that is they do not have a left recursion. So along with that I will be adding the new set of productions beta 1Z, beta 2Z, beta S, Z. So what is this Z production? Again I will be adding in the step 2, that is Z is equal to alpha 1, alpha 2, alpha R. So what are these alpha 1, alpha 2, alpha R? These are the productions which are here, you can observe. That is A productions which contain this left recursion, excluding the first symbol, the remaining are alpha 1. So that I will be adding as a Z production along with alpha 1Z, alpha 2Z and alpha RZ. So these are the new set of Z productions I will be adding to the set of productions P1. And all other productions which are already in the GNF to be added to the production set P1. Therefore, G1 is the required grammar in GNF. So this will be the procedure to convert the grammar into a GNF. Let us see some examples. First one, find the grammar in GNF. So you can observe S derives AA or 0, A derives SS or 1. So these are already in the required form. And you can observe that there is a left recursion. So here you can start S derives A derives SS. So you have a left recursion. So here there are no null unit productions and useless symbols. So productions are already in GNF are S derives 0 and A derives 1. And what we have here is a cyclic left recursion. So for which we have to start with replacing S derives A1 and A derives A2. Then the productions becomes A1 derives A2 or 0 and A2 derives A1 or 1. So here you can observe that it is of the form AI derives AJ alpha where I is less than J, which is the required form. Now here A2 derives A1, A1. So AI derives AJ alpha, where here I is greater than J, which is not in the required form. So we have to consider this production and get it into a required form. So using the substitution rule, what I can do here is only for the first variable I'll be replacing by the A1 production. So I'll be getting A2 derives A1 A1 1 becomes A2 derives. So the first A1 I'll be replacing by A2 A2. So I'll be getting A2 A2 followed by A1, and this A1 can take 0 also. So 0 A1, and this is already the production of A2. So I'll write it as it is. Now you can observe this is of the form A2 derives A2, A2, A1. So here again you have a left recursion. So this is we have to eliminate. So eliminating the left recursion from A2, what we can consider here is, so this is of the form A derives A alpha. So where alpha is this, alpha 1 is this. So now we'll be getting the production A2 derives 0 A1. This is already in the required form. This is also in the required form. Along with that, I'll be adding the new production 0 A1 alpha, 0 A1 Z, because these are like beta 1 and beta 2. So I'll be adding the new productions. A2 derives beta 1 Z, beta 2 Z. This is beta 2 Z. That is 0 A1 Z and 1 Z. And for Z, I'll be adding the production Z is equal to A2 A1. This is your alpha 1 and alpha 1 Z. So this is your alpha 1 Z. This is alpha 1 Z. So now A2 productions are in the required form. You can observe this is starting with the terminal followed by variable, or a terminal alone. So terminal followed by variables, terminal followed by variable, terminal, and this is only A2 productions are in the required form. Now you can substitute the A2 productions in the A1 productions and get the grammar in the required form. So substituting A2 production in A1. So this one I can get the A1 productions in the required form. So A1 productions will be, so 0 A1 A2, 1 A2, 0 A1 Z A2, 1 Z A2 followed by 0. So that will be the productions of A1. Now substituting the A2 production in Z, I'll be getting Z production also in the required form. So the Z production will be only for first A2, I'll be replacing by 0 A1 A1, then 1 A1, 0 A1 Z A1, 1 Z A1. And again for each of these production, I'll be having Z. So you'll be getting totally 8 productions for Z. So which is written here. That is here. So this is here and this is with Z. Thank you.